Okay, good. All right, so I just wanted to make sure I recorded this. So it is now being recorded. All right, so back to what I was saying. The normal distribution has this pretty symmetry. And actually, I am sharing the screen. Okay, good. And like I said, it's sometimes called the bell curve. A couple things to expect. It always has a line down the middle that's like a line of symmetry, meaning that the piece of the curve on the left here, and then the other piece of the curve on the right are supposed to be identical. Now, my picture is not very good, but you're just sort of trusting me that that's the case. And what always goes in the middle of the curve is the mean. It's always in the middle. And then a couple other things that matter when you identify a normal distribution, you would have mu, which is the mean. This fancy symbol here stands for mu. And then this other symbol looks like a sideways 6. That stands for something called the standard deviation. And they measure different things. So we talked about standard deviation. I had given you a video to watch after the first week of class. Standard deviation, fundamentally, it measures the spread of data. Is data close together or is it far apart? So I'll try and explain that more in a moment. And mean measures, that measures the center of the data. Okay. So those are two important things to keep in mind. And then there's this thing called the bell curve. Now, you might say, why is this so interesting? Why do we care about it? It turns out that the normal distribution shows up in lots of places that people don't expect. So for example, hold on a second, let me just do this, add a page. So IQ scores are an example. Typically IQ scores, which maybe you've taken one in your life, you might have been given one by a school and not known it, but usually they're typically centered around 100. IQ stands for intelligence quotient. It's usually your intellectual age divided by your chronological age. So 100 is like 100%, meaning that your intellectual age 100% matches your chronological age. If you have an IQ of like 120, maybe some number up here, then that means your intellectual age is 20% bigger than your chronological age, your biological age. I don't know if I put much faith in IQ scores. Some people don't score well on these tests, but they're very bright and creative in many ways. So I'm not sure what they mean. But anyway, it turns out that if you measure a whole bunch of human beings with IQ scores, then they end up following, you graph all those scores, they end up following a distribution like this. So for example, let's say you did the following. Let's say you made an x-axis here, and we said, all right, I'm going to put all the people whose IQ is from 40 to 50, and then from 50 to 60, 60 to 70, 80, 90, 100. We'll go out here, 110, 120, 130, 140. Oops, sorry, my pen stopped writing there for a second. 140. Okay. Okay. And then what would happen is that you would find that the graph was sort of the biggest bars, the highest amounts of people would be here in the middle. And then as you went further and further away from the mean, you would get smaller and smaller amounts of people in those groups. And you'll notice that this group generally, this graph seems to look like a normal distribution. So if you had millions and millions of people and you made each bar, so we made the bar width here. So we look at this bar I'm shading in purple. It has a width of 10, right? We can make the width smaller, and then the bars get closer together. And eventually the curve will smooth out and look like something like this. So IQ scores seem to follow normal distribution, which is very surprising. Why would this graph describe so many natural phenomena? If you were to do the same thing with heights of teenagers or something like that. So maybe the average ninth grader in a high school is 65 inches tall, and maybe the standard deviation of heights is 2 inches. So what you would find is here's 67, here's 69, here's 71, and then down to is 63, down to again is 61, then 59. What would happen is you get this normal bell curve again. And it's strange that human beings seem to follow the normal distribution when we measure them in certain ways, like this case height, or a measure of intelligence like IQ scores, and all other kinds of things. Okay, any questions so far about the normal distribution? Okay, I'll say one more thing about it, and then we'll get to work on some problems. So the normal distribution has this nice bell curve. It has an equation. It actually looks like this: 1 over the square root of 2 pi e to the negative x squared over 2. That's a wild looking equation when you think about it. It's got pi in it. You may remember that number, some of you. Pi 3.14159, and then it just keeps on going for a long time. E is another number like that. That's less well known. People don't know about E, but E is about 2.712 something. It keeps on going forever like pi. There's no pattern or anything like that. So it's pretty amazing that this equation, which has pi in it, which is this crazy irrational number, and E, which also is another irrational number that shows up in many places. For some reason, this equation does a good job describing natural phenomena in the real world. Okay, so having said all that, what are we going to concern ourselves with? Well, what we're going to do is we're going to have a normal curve, and we're going to say things like, what's the area under the normal curve, say, between two numbers? Let's use these numbers we were using before. I mentioned that the mean height of all 9th grade students in high schools across the country is 65 inches. And the standard deviation of those heights is 2 inches. So I might say to you, what percent of students, right? So this might be the question. I'll write it on a new page. Sorry, my screen jumped there. Percent of students that are between, and I might say 63 inches and 65 inches. I could ask questions like that. Now, that's a lot to write. Here's something else you can write instead. Instead of writing this whole sentence, you can just write the following. You could write, sorry about that, my screen jumped. P 63 is less than X is less than 65. If you just write that to me, I'll know that you mean the percent of kids that are between 63 and 65 inches. Okay, so there's all different kinds of questions we can answer. All right, let me pause for a minute. Any questions so far? Okay, good. So just stop me. I don't think I'm a scary person. Plus, you could always just direct message me. If it pops up, I will blank out the screen here. I won't share, and I'll try and answer your question individually or speak it to the whole group. Okay, so this question really corresponds to the following. Here's 63 inches. We're really saying, what area is in this part of the curve? That's what we're asking about, this normal distribution. How do we find area under the normal distribution? That's going to be our goal for today. And then we're going to use this problem in many different settings to hopefully understand things a little bit better. Okay, so that's going to be the goal. All right, so let's go back to that document that I shared with you. What you'll notice is, if you look at it, here's the title: Normal Probability Calculations, Examples of Normal Distribution, so forth. And there's some words here. It says normal chart, right? It says z-score and area examples, whatever that is. And then what you'll do is, oh, and by the way, I should make a comment. This is in week 3 notes. So if you were to go to your course in Canvas and then click on the side where it says modules, you'll see all our previous notes, right? And then week 3 notes. That's what you do. If you click on that link there, you should land on this document. Okay, let me just pause for a second, make sure everybody's with me. Does anyone have any issues finding the document?
Can you please repeat that?
Oh, how to get to it? Sure. So you go to modules.
Yeah.
Go to Canvas. And probably when you get to Canvas, I think it looks like this for you. You might see a bunch of your courses.
Click modules.
Yep. So they click on
Click
this.
modules.
Yep, modules. And then at the bottom where it says week 3 notes, there's a link there, and you click on this link. You should take you to the document.
I have it.
It's not working.
I had it. I just said I have. Excuse me, Professor. I have it, but I thought you said you was using another document.
Oh, I'm sorry. My bad. My bad. All right. Yeah, I think you had said it before, because before you asked me, was it week 3 notes? And I said yes, you had it right before. You were already there. Okay. How about anybody else? So Regina's all set.
Normal proper. No.
Say again.
No, I have it.
Okay, good. All right. Everyone else is okay too? All right. So what you're seeing here, if you look at this document, is pretty wild, actually, how it wants me to sign in. Hold on a second. All right, so that worked. So what's pretty wild is if you, oh, I see what's going on here. All right, hold on a minute. It's just going to make me sign in for a second. Just bear with me. Okay, that worked out. I don't know what that was, but it's good now. Okay. What you're seeing, if you look at the top here, is what looks like this normal distribution I've been describing. And what I want you to notice is, notice how on the bottom of the picture here, you see a little thing that says Z, right? So you see this little Z there, right? And then you also see, oh, sorry about that. It jumped on me. Okay, you also see this area shaded in to the left. So you'll notice that this is, and what this is trying to tell us is that that's what a normal distribution looks like, this bell-shaped curve. And that shaded area to the left of this number Z, this is number Z on the bottom, is given in the chart below. So I want you to look in this chart, for example, what you'll notice is on the left-hand side of the chart, it says table A, and right underneath it, it says Z, right? And then you'll notice there's negative 3.4, and then negative 3.3, and negative 3.2. So you should be able to see that on the left-hand side of the screen. Okay. And then if you keep going onto the next page, there's another chart. On this chart, notice where Z starts. Z starts at 0.0, then 0.1, and 0.2, and so forth. And it goes all the way down to 3.4. Okay. All right. So let's look at the chart just again to get a sense of it. Let's go back to the beginning. You'll notice that this first chart, this is on the second page of the document, has all negative Z-scores. And then the second chart over here has all positive Z-scores. Whatever those things are, this Z variable, I'm calling it a Z-score now. So used to saying it, I forgot to tell you. So it's sometimes called a Z-score, or just you call it Z. Okay, so what we're going to do is we're going to try and answer some questions using that table, and we'll see what we can do. So this the page 4, I believe. It says problem 47, table A practice, and A says the following: Z is less than 2.85. So we're going to do that problem together. Z is less than 2.85. Okay, bear with me for a second there. Hold on. Okay, so Z is less than 2.85 is what we want to know. So what we do is we go back to that table, And here's how you're going to do it. So I want you to look on the left-hand side of the table. The first column is called Z, and go down until you can find the number 2.8. Now, the way I have it lined up, I have it lined up just with the bottom of my screen. You can see 2.8 right there on the bottom. Can I just have like people say yes to me if they can see the 2.8 I'm talking about?
Yes.
Okay, good. I got a yes from a few people. Anyone else?
Yes.
Okay.
Yes.
Good. Thank you. It's I appreciate it. All right, that's good enough for me. You know, I'm used to teaching in person, so I'm teaching in person. I can look at your faces, and on the screen, I can't look at this screen and look at you. And also online, it's more challenging. But when everyone's in the same room, I can look at you, and then you give me a look that says I'm good, or sometimes you look at me like you're totally confused, and then I know I need to do something different. Okay, so the question we were trying to answer was Z is less than 2.85. So if we look at this chart now, the last row I have highlighted there, I want to highlight it, but you can see it says 2.8. And then what I want you to do is notice across the top, I'll show you what I mean here. Table sort of laid out in an interesting way. So what you'll notice is there's a column that says Z. We're down on the side, we found the number 2.8. And if you look across the top, you'll see like 0.00, and then 0.1, well, 0.01, 0.02, 0.03, and so forth. 0.04, 0.05. The last number up there is 0.09. What I'd like you to do is this, like look at the 2.8, look at the 0.05, and go across and down, and you'll find a decimal in the chart right there. That's Z equals 2.85. So there should be a number there. Let's go look at it. And if I look here, 2.85, I think I see 0.9978. Let me know if you disagree with me or don't know how I got it. I think that's what it is, right? 0.9978 is what goes with it. So that's the number I'm seeing in the table. And here's what you need to know. So this number, this is the area to the left of Z equals 2.85, right? We had solved the problem. Z was less than 2.85. That's what we had done. Okay, so let's pause for a minute. Any questions about what that number means? Let me draw you. Yeah, go ahead.
You have to go over that again. I'm sorry.
Sure. Yeah. What this, no problem. You got it. So what this chart does is, oops, sorry, wrong button. You can mute. Yeah, a second. Let me just do one thing, Regina. I'm just going to mute it. All right, but I'll still talk to you. Ready? Okay. So let me share the screen again. Okay. So what we were trying to do is, here was the original question. The original question said find the probability or the proportion of people or percent of people that are less than Z equals 2.85. And so what we do is we go in the chart and we look for 2.85. So on the left-hand column, down at the bottom, near the bottom of my screen, you'll see a 2.8. You can see my mouse hovering there. And if I go across the top, I'll find a 0.05. So you can see my arrow thing hovering there. If I go down to the bottom, I see this number 0.9978, which goes with the 2.8 over on the left. So what I was really doing, Regina, was I went in the chart, I went down the left-hand side, I found 2.8, and then I went across until I had the 0.05 on the top, and I was looking for the number in the chart that was right there. Does that make it better, Regina?
This see, I can see it from here. Excuse me, I have a cold, but not the other way. Now I see it. How you did? You went down to 2.8 and across to 2.05.
Yep, correct. That's exactly right.
Okay,
And
but
so
let me
what's
ask you. Did you?
Yep.
Go ahead, Professor. I'm sorry.
No, you go. My bad.
But did you? How did you get that number? Did you time? Did you do multiplication?
Oh, you mean the
or
2.85? Or how did I get the
yeah? How
0.9?
did you get the? Yeah.
So two things. First off, the questions are going to be like the 2.85 is either going to be given to you. There will be a way to find it, but we haven't learned that yet. So like where this number's
Okay.
coming
All
from,
right.
just sort of presenting it to you. But we're going to do questions where you
Okay.
find it. And then the second thing, 0.9978. So that's what I want to do now is just show you guys what that means. So I'm going to draw a normal
Okay.
distribution. Does that make it better?
Yes.
Good. All right, so here's the normal distribution again. And remember what I said to the group at the beginning was that in the middle is always the mean. Okay, so we don't know much about this Z value yet, this thing I've been calling the Z score, but I'll tell you the following. Here's one special fact. Z equals 0 always goes with the mean. So that's a rule. Z equals 0 says it's like a way of saying you're in the middle of a normal distribution. That's what Z equals 0 means. Z equals 0 means, I'll say it this way again. We are in the middle of the normal distribution. Okay. Now, something else you should know. On this side over here, those are all the positive Z's. Positive Z's are always on the right side of the mean, and negative Z's are always on the left side of the mean. Okay, so these Z scores, they sort of like tell us like how far we are from the mean. That's what they do. Again, I still haven't told you much about them yet, so you should have just trusting me with these things, but that's sort of what they do. They kind of tell you like how far we are to the left and right. So I'll let you just look at that picture for a moment. Okay, Z equals 0 is always in the middle. And then positive Z's are to the right of the mean, and negative Z's are to the left of the mean. And that's just always a thing that we need to know. Okay, so now that I've said that, let's actually draw a picture that goes with this problem. So in this problem, we looked up in the chart, we got 0.9978. That was the answer to that question. Here's the picture you can draw that goes with this. So we're going to draw a normal distribution. We're going to put Z equals 0 in the middle. And we're going to go out on the right-hand side over here, and we're going to put Z equals 2.85. That's what we're going to do. Z equals 2.85. And I want you to draw a vertical line going up like this. Okay. All right. So now that I've done that, what I'm going to do is shade in that area all the way down to the left, all the way down. Technically, this stuff, William, it goes all the way to the end, like down forever, further than we can imagine. Okay. So it turns out that this area here is equal to 0.9978. So that's what we just did. When we looked in the chart and we looked up the 2.85, and Regina and I talked about it, the number we got, 0.9978, is the area that's left, is to the left, I should say, of Z equals 2.85. That's what this chart does. Okay. So what I like to do is just find a few more areas and talk about some clever things we can do in this chart. Let's do that. Go back to some of the questions that are in this document here. Hold on a minute. Here we go. So, oh, that's interesting. There's a bunch of questions there. There's a whole bunch of them. Before I get to question B is saying Z is greater than 2.85. I don't want to do that yet. I want to ask you a couple of questions on my own first, and then we'll get back to the questions that they gave us that I put in that document for you. I add a couple of blank pages here. Okay. So let's do this. So suppose I said PZ is less than 1.63. PZ is less than 1.63. I'm going to do this one with you, to do one more with you, and then we're going to go, I'm going to give you a problem to try on your own. So what we're going to do is we're going to look in that chart again. We'll scroll down in this chart. I'm looking for 1.63 for Z. So I can make the screen a little bit bigger. Let's try that. So here we are. I'm going to take the 1.6 and line it up with the bottom of my screen. And then I'm looking for 03 on the top, right? So I can see the 1.63 is right there. You can see my 1.6, my mouse is highlighting that. And then the 03 is up here. And if I go down, I see 0.9484. So there it is, 1.6, 03, 0.9484. So what I'm doing is in the chart, this is Z. I look for 1.6, the 0.03 on top, here, across, down, circle a number. I'm getting 0.9484. So that's what we get. What that's telling us is that if we were to draw a normal distribution and put Z equals 0 in the middle, then we can go over here, mark off Z equals 1.63. We could go up and we can shade. Hold on a minute there. I can shade all this area to the left. And that area is 0.9484. So that's what we just figured out. Okay. Any questions or comments? Okay, so I'm going to say a couple of things. We're going to do a couple more of these problems with finding areas and do some clever stuff. But as we go through this, you might be thinking, like, you know, my other students here might be thinking, well, you know, why do we care about this normal distribution? What kind of problems can we answer? Go ahead, Regina. What are you thinking?
I might, because I kind of got lost when you did the, I'm embarrassed to say I kind of got lost when you did the normal, you know, when you did the, I wrote it down, you know, Z equals 0, Z equals 2.85, but I'm still not saying that you get the 94.84 from.
Oh, okay. So that was for this question. So I made up a question, a new one.
Oh,
For Z equals less than 1.63. That's where I'm getting that number from now. So let's see if we can see it. Ready? Here's the 1.6 over here on the left. You can see my mouse there, kind of. In the lower left part of the screen, 1.6. And then the 03 on the top. And I go down and there's the 0.9484 right there. Does that work for you?
no, show me again because I'm sorry. See, I can't, for some reason, I can't see your pointer.
Oh, you can't? Okay. So what I did was that, let's go back. I'll have to do it on this screen and then go back.
Now I see it. Now I see it.
Yeah. So I just looked at the chart. I went, here's the 1.6 over here. Here's the 0.03 over here. And I went across and down and I found this new number, 0.9484. Does that make sense?
Yes.
Okay, good. And all we have to know is that this chart always tells you all the area to the left of a particular point, is what it always does. So in our case, we had Z equals 1.63. That's over here somewhere. And the chart told us that the area to the left, all this area over here, is 0.9484. That's what the chart told us. Okay. All right, let's try some more, because there's other things we could ask when it comes to these kinds of questions. So we can ask more interesting things maybe. All right, so let's see what we got. Ready? So we look at this question. Part B says find the probability that Z is greater than 2.85. So that's going to be interesting to talk about. So let's try and draw a picture for that. So probability Z is greater than 2.85. So here it is. Got a normal distribution. We know Z equals 0 is in the middle always. So Z equals 2.85 is out here somewhere. And I'm going to draw a vertical line. Now here's what I've got to remember. When I go look up in the chart, Z equals 2.85. We did that earlier tonight. We got 0.9978, right? That's what we got, 0.9978. So here's what you need to remember. When you look up the area in the chart and they give you 0.9978, you need to remember that that's the area to the left of that Z-score. And that's how the chart's written. It never gives you area above a Z-score. The chart only gives you area less than a Z-score. So the problem, of course, is that this question is saying, what's the probability that Z is greater than 2.85? They want to know what's the probability that we're up here instead. Okay. And it turns out, here's the second fact you need to know about the normal distribution. The total area is equal to 1. And that kind of makes sense. You could think of it like 100%. 100% is really like the number 1. And so the total area is equal to 1. So if you want this little green area up here, we can do 1 minus 0.9978, which I think is 0.0022. Okay. Let's pause for a minute. Do you have any questions for me about that? We're good? Okay, so 0.0022, that's what we have there. So that's how you can get all kinds of areas. Let's go back to the document. Let's see. So look at part C. Part C says find the probability that Z is greater than negative 1.66. All right, so let's go write that down and do that question. Probability that Z is greater than negative 1.66. So here's the picture we would draw. Draw a picture like this. We're going to mark off a negative 1.66. Now we need to be careful. Z equals 0 is in the middle. A negative Z-score is to the left. So it's going to go over here. Okay. And the area they want, so this area is above it. They're asking us for all of this area. Now we know that the chart's not going to give us that. The chart only gives us area to the left. So it gives us this area down here. So let's go look it up and see what we get. Look in the chart here. I'm going to go up. I need the chart with the negative Z-scores, which is on the next page. There it is. I need negative 1.66. So I'm going to just show you what I'm doing on the other page, and then we'll look in the actual chart. So what I'm doing here is I've got my Z chart as always. I've got Z here. I'm looking for negative 1.6, and then going across is 0.00, 0.01, and somewhere over here is 0.06. Find that number and that number, go across, go down, and find this number in the chart. So let me go see if I can find that and see if you guys agree with me. I think it's 0.0485. I think that's the number in the chart. I'd like to know if anyone disagrees with me or has a question about that. Okay, so let's go put that in our graph. So now we know that this purple area down here is 0.0485. Notice how that's not the area I really want. Okay, I really wanted this blue area up here. But keep in mind that under a normal distribution, the total area is always equal to 1. And so to get this area in this blue spot, we're going to do 1 minus 0.0485, which, what is that? 0.9515, I believe. I think I'm subtracting correctly today. Okay. So what we just figured out is that the probability that a z would be greater than negative 1.66 is 0.9515. I should mention, some of you may like percents better. So you could take this number and if you want, write it as 95.15%. So that's always an option as well. Okay, let me pause for a second or a minute. Any questions about that? Okay, there's another question waiting for us, and this one will require us to be a little bit more creative. So what we'll do is, oops, sorry, too far. Look at part D. Part D says negative 1.66 is less than z is less than 2.85. So here we go. And now they're asking for the probability negative 1.66 is less than z is less than 2.85. Okay. All right. So let's draw a picture of it and then we'll start to work on it. So here we go. Here's our normal distribution. Some of you probably look at my picture and think it's not very symmetric. Like it should be perfectly symmetric down the middle. So you'll just have to, I have to ask you to forgive me about that. My picture doesn't look so great. That makes it look a little better maybe, but it's not perfect. Okay, so keep in mind always z equals 0s in the middle. So then z equals 2.85 is out here somewhere. It's positive, so we go to the right of z equals 0. I'll put a little vertical line there. And then the negative 1.66, that's going to be over here on the left. Like that. Okay. And this question is asking us for the area in between. It wants that red area. Okay. So that's what they're asking for. Now we have a problem. Our chart does not do this. Our chart only gives us area to the left of z-scores. Area to the left of a given z-score. So, for example, let's consider the 2.85 right now. I'm going to go look up the area that the chart gives me. You might remember it from before, but let's just look it up again real quick. 2.85. And if you look on the chart for 2.8, here it is, I put it right on the bottom there. 2.85, I'm seeing 0.9978. 0.9978. Now that should make sense. We did that earlier this evening. Okay. Let's go look up the area that goes with negative 1.66. We just did that a moment ago, but I'll go back again. So here we go. Negative 1.66 we want. So the negative 1.6 row is on the bottom of the screen there. And 6 on the top, we get 0.0485 again. Some of you probably already remembered that. 0.0485. Okay. So the question becomes, what can we do with this area, this purple number, and this green number to get the red area in the middle? That's what we're suggesting. Some of you may have an idea. I'll let you try it if you want. If you want to tell me. My hint would be this. Please keep in mind that z equals 2.85, this area underneath it is the entire area to the left of 2.85, all the way down forever. That's what this number 0.9978 is telling us, that every piece of area. So it's all the green area all the way down forever is 0.9978. The purple area, 0.0485, starts here, and that also goes to the left, because that's how the chart works, right? The chart only gives you area to the left. So if we think about it, the green area is 0.9978. This purple area over here is 0.0485. And if I want the red area in the middle, this stuff, I can just take the green area, which I had, right? So the green area kind of looks like this as a picture. That's what it looks like. We know that whole area is 0.9978. And then we inserted this little purple area down here at the bottom. And that little area by itself is 0.0485. And I think now you know what we can do with the green and the purple to get the red. And so you're just going to subtract them. So that red area there in the middle is going to be 0.9978 minus 0.0485. Okay, let me pause for a minute there. Any questions about that idea? Or are we okay? I think I'm getting, for an answer here, 0.9493 as an answer. Okay, any questions or comments about this? Yes, no, maybe. Okay, so you're taking, like, we have to use the fact that the chart only gives us area to the left, and then using that chart, we can subtract two areas to get an area in the middle somehow. So that was exactly the plan here.
I'm sorry, Professor, do they have a video on this I can go back and keep practicing with?
Yes,
Or you
so
have to, it's on the,
I'm recording this lesson for you. So, and I should show you from last time. I think I did it. So back in, just so you can see what to expect.
okay, and I see a lot of the modules have, okay.
Yeah. So if I look, for example, in modules here. So here we go. So you should notice in week 2 modules, week 2 PowerPoints and notes. The last link there says videos for week 2.
Mm-hmm.
So if you click there, I'll show you what it looks like. I have 2 links here, and these 2 links are the links for our last lesson. And my plan is, after tonight, after we're done, I will do the same thing here. I will post links again here, so you can go back and look at this lesson again. Sound good?
Okay.
Yeah, it'll definitely be there. I remember you mentioning to me last time, Regina, that you like to go back and like rehearse it. You're not the only one. Other people like to do that too. So
I haven't had a chance because after my father's funeral, but between the next 2 I'm gonna like get deep heavy into it. Like I said, it's hard for me to understand.
So I'm sorry.
I'm trying to keep practicing and practicing.
Yeah, that'll help. You're gonna hear my voice a lot, so I just want to say I'm sorry in advance for that.
No, it's okay.
And if you're having a hard time falling asleep, just listen to this lecture. You'll go right to sleep. It does to everybody. That's what my family says to me. Like, oh, how do you talk about that, Dad? How do you talk about that stuff all the time? So, all right. Does anyone else have any questions for me? Anyone else in the group? Okay, so here's what I would like you to do. In the document we were just looking at, here's what I would like. We go to problem. Let's see, do I like that question? What question do I like? I'd like you to take a few minutes and maybe try this problem 49. So if you just take a minute to try those and see what you think, that would be good. I'm just going to stop sharing for a moment. I'm just gonna say, I'm gonna take just take like 2 minutes to try it. Okay, so let's take a look at this problem. The first one is from Z is from negative 1.33 to positive 1.65. So let's try that. Okay, so let me get a new screen. Let's do this. So we can say P negative 1.33 is less than Z is less than 1.65. That's what we can say. Okay, let's try and draw a picture of this. So here's our normal distribution. Let's mark out over here, Z equals negative 1.33. And then over here, positive Z equals 1.65. And the same reasoning is going to hold down. So if we go look up the area for both of these, let's go do that. Let's look up the area for 1.65 and also look up the area for negative 1.33, whatever this turns out to equal. Let's go see. All right, so in our chart, 1.65, here we go, we'll go up here. 1.65 5. I'm getting 0.9505. So this area here is 0.9505. And we need to remember is that area is all of this. All of that area is 0.9505. Okay, which is too much because we really just wanted the area in between. We wanted this red area here. Okay, let's try and get that green area. The green area is right here, like this. Let's try and figure that out. Okay, so to get the green area, we're going to go back to our chart and look up negative 1.33 because that was the other z-score they gave us. Negative 1.3. Here we go. Line it up with the bottom of my screen there. Negative 1.33, and I'm getting 0.0918. So this area here is 0.0918. That's what we have. And if I want the red area, I think you can tell to get this area in between, we're going to take, to get that, I'll just write it this way. We're going to take 0.9505, and we're going to subtract off the area that's below z equals negative 1.33 or 0.0918. That was the area we just looked up in our chart. Let me do that subtraction for you. 0.9505 minus 0.0918, and I am getting 0.8587. So that's our area. Okay. Any questions or comments about this? All right, good. Let's go back here for a minute and let's look at one more type of problem before maybe we take a little break. Talk about the schedule in a moment. Okay, so here we are. These problems 51 and 52 talk about working backwards. So if you look at problem 51A, it says find a 10th percentile, or 52B, find the 63rd percentile, things like that. When you're working backwards, the key things to realize here is that they're giving us areas in these questions, and they're asking us for z-scores. So let's talk about why that's different. If we go back to the previous question, the one we just did, for example, notice in problem 49A and B, we were given z-scores, and we had to find the area by using the chart. These new questions, what's happening here is we're giving you areas and asking you to figure out the z-scores. So we're going backwards, using the chart in reverse. So we're going to do problem 51, part A. So in that question, they're saying the following. They're saying find the 10th percentile, whatever that means. So the 10th percentile, what that's really saying is it's the z-score, or the z-value, we'll say, or z-score, with an area of 10%, or we could say 0.1 below it. So notice what's being happening here, right? We're giving you the area of 10%, and we're saying what z-score has 10% of the area below it. So here we go. Let me draw a normal distribution again. And here's a question for the group. I don't know if we thought about this yet, but earlier I told you that the mean is always in the middle, and that always goes with z equals 0. So my question to the group is, without even looking in the chart, what percent of the area do you think is below z equals 0? If it's right in the middle of the graph. You don't have to answer it out loud, just think it to yourself for a moment. If z equals 0 corresponds to the mean or the middle of the data, what percent of the data would be below z equals 0? Hopefully you're thinking, oh, 0.5, right? Because that's true. 0.5 of the area is below z equals 0. In this case, you're saying that there's some kind of number where 10% is below it. I'm going to go over here somewhere. I'm going to put a z equals and a question mark because I don't know what the z-score is. What I do know is that the area below it, this area down here, is 10%. Or better yet, as a decimal, 0.1. Okay, so let's pause for a minute. Any questions so far? All right, so we're going to get the z-score that goes with that. And here's how we're going to do it. We know the area is 0.1, so let's go back to our z-chart that we had earlier. Bear with me while I go back to it. So here we go, getting there. Sorry for the slow scrolling. And what you'll notice is what we're going to do now is look at the areas in the chart. And if we look at all these areas, they're all like a lot of 0.9s, 0.8s, and so forth. I don't see anything with 10%. See, what I'm trying to do is the following. I'm looking in the chart like this. Here's my plan to answer this question. So there's my normal chart. Here's my Z. Somewhere in here, in the body of the chart, I'm going to find like 0.1000 or something super close to it. And what I'm going to do is I'm going to look out here and up here and get the z-score. That's my plan. So notice in this question, I'm starting with the area. That's what I'm doing. I'm starting with the area and I'm looking out to the left and up to the top to try and figure out what z-score would capture that. So let's do that here. I see two numbers that are really close. So if you look in here, looking for, well, we're looking for 10%, sorry. So I think I see one number that's super close, actually. If you look in the body of the chart, somewhere you'll find a decimal. It says 0.1003. So once you look for that number, it's on the page with the negative z-scores. It's over on the right-hand side. It says 0.1003. So what it looks like, the best I could find was this. So here's my z-chart. Looks like this. Somewhere over here is a 0.1003. And if I look to the left, or look up to the top, I will see a z-score. It looks like negative 1.2 and then 0.08. But let's make sure we agree. Negative 1.2 and 0.8. Yeah, I think I see that. Let me scroll it down a little bit for you. So if you look now at the bottom of my screen there, you'll see all the way on the right, the second to the last number on the bottom right is 0.1003. And you'll notice the z-score that goes with that is negative 1.28. So that's how you answer, that's how you use this chart in reverse. Okay, let's do one more question before we take a break. Back in the questions we were looking at. So back to that problem where we're working backwards. Here we are. Problem 51B says 34% of all observations are greater than Z. 34% of all observations are greater than Z. So let's go do that. Somewhere, let's try and draw a picture of that first, actually. So it says 34%, right, of all observations are above Z. So a percentile, like the previous question we did, 10 percentile means that 10% of the area is below it. So this is sort of like the opposite of a percentile. We're saying 34% of the area is above it. So the picture for this would look like the following. Here's our normal distribution. Let me go over here. I'm going to mark off a z-score. And I'm going to fill in an area above it. And I know that that area above it is 0.34. Okay. Let me pause for a minute. Any questions about this? Yes, no, maybe. Okay, good. So without working too hard, I think we know how to do this. What's the area below the Z-score? If 34% is above, how do we get this area down here? 1 minus 0.34. That's what you have to do. 1 minus 0.34. Okay. Or that's, I think, what is that, 0.66? I think that's what it is. Okay. So why did I do that? I want the area to the left because that's how the chart works. The chart only works with area to the left. So here we go. I'm going to go back in the chart. I'm going to look up an area as close as I can find to 0.66 and then get the Z-score that goes with it. Okay, so 0.66. I'm looking for that in the chart. Okay. So I see two numbers here. You'll notice there's a 0.6628. That's really close to 0.66. And the number before it, 0.6591. You could use either one of those. I'd be okay with it. I'm sure someone might be thinking, well, Dr. DeMarina's point, that's me, Dr. DeMarina's 0.6591 is closer to 0.66 than 0.6628 is. And if you want to do that, you can. I'll take either one of them here, though. It's not super precise. Okay, any questions or comments? So the Z-score that goes with that, okay. So I looked in the chart now, right? Here's what we did. We looked in the chart, and Z, the closest number, we found a 0.6628. And I start with that number because that's really close to 0.66. If I look over here, I get a 0.4. And if I look up here, I think I get an 0.2. So Z equals 0.42 is the answer to that question. Okay, any questions or comments about these? All righty, good. So I'm going to stop sharing for a moment and make a comment. So hold on for 1 minute here. Let me just see if I can. All right.